So the last section in chapter 2, this is the last thing that will be on the test next week, is about phase shift. And we're not going to do sinusoidal curve fitting, although it's really a useful thing, and the most common use for sine and cosine graphs is to model data, but it's not in our curriculum. So we're just going to look at how to graph sinusoidal functions of the form y equals a sine, and here's the difference, omega x minus phi plus b. So the difference here is this is the one transformation that we haven't done yet. So we did omega, which was the horizontal stretch and compress. We did A, which was the vertical stretch and compress. We did B, which was vertical shift up and down. So this phi is going to cause a horizontal shift right and left. So that's what we're going to be looking at. So we're going to graph sinusoidal functions. And remember, sinusoidal means sine or cosine. We're going to focus just on sine, but everything we learn applies to the cosine also. So we've learned that the amplitude of the graph of y equals a sine of omega x is a, so that's called the amplitude. Nice that they use the letter a. And the period is t equals 2 pi over omega. So that's going to stay true. But if we're given a function that has a difference or a sum, but see the basic form is with a difference, inside the argument, the first thing we need to do is factor out the omega from the rest of the argument. So we'll rewrite y equals a sine omega x minus phi as y equals a sine, factor out the omega. So from the omega x term, that leaves an x, minus phi over omega. And if that looks like algebra magic, just think about when you distribute back, will you get what you started with? Yes. So that's a correct factoring out of omega. And omega is always going to be positive for us, just to avoid confusion. And omega is always about the horizontal stretch and compress. So remember, we always said either omega is between 0 and 1, or omega is bigger than 1, but omega is never a negative number. We can always get rid of negatives because recall that sine of negative phi equals negative sine phi, theta, sorry. And cosine of negative theta equals cosine of theta because of even odd properties. This is odd, this is even. So you never need to have a negative in your argument. So the symbol, if you see it printed, it looks more like this. I write it like this because it's faster for me. And I checked with my Greek-speaking friend, and she says phi, but you will also hear people say phi, but it should be phi. So as the argument, omega x minus phi, so this is your argument, as it varies from 0 to whatever the period is, the sine curve will trace out one cycle or one period. So let's solve omega x minus phi for 0 and solve that for x. So that means get the x by itself on one side. So we'll have omega x equals phi. And so when x equals phi over omega will be the beginning of the graph. So the graph used to start at 0. Now it's going to start at x equals phi over omega. So this is the horizontal shift. And then if we solve omega x minus phi equals 2 pi, which is the basic period, we'll see that then we get omega x equals 2 pi plus phi. So we get x equals 2 pi plus phi over omega, this will be the end of one cycle of the graph. So see, everything is just moved over phi over omega. So the function's graph will trace out one cycle of the sine curve as x goes from phi over omega to 2 pi plus phi over omega. So here's a picture of, it's called the phase shift. So the phase shift is this phi over omega quantity. So see how the graph now starts at phi over omega. It still does its one cycle in a width of 2 pi over omega. And then the cycle ends at phi over omega plus 2 pi over omega. See how these are the same. Another way to get the same information would be to solve this compound inequality. So we just solved it in two pieces. So which way has the graph shifted? To the right. This is the confusing one. When we have omega x minus phi, we shift to the right. So that matches what we studied in section 1.7. So we call the quantity phi over omega the phase shift of the graph. And we say the phase shift is to the left if phi is negative quantity, because that means you actually have omega x plus something. And it shifts to the right, like we just saw, if the phi is positive. Okay, so here's a summary of how to draw these graphs. You find the amplitude and the period. So the amplitude tells you how tall is the graph going to be, and the period tells you how wide is the graph going to be, right? Because this is from A to negative A, so this is 2A. So you need a box, 2A tall and T wide, to draw this graph. So then you're going to find the starting point of the cycle, which is x equals phi over omega. And then you're going to find the ending point of the cycle. And then you're going to divide this interval that you find into 4 equal subintervals. So this is because the graph has 4 parts, just as we've been drawing them without the horizontal shifts. So there's part 1, part 2, part 3, and part 4. So every sine and cosine graph has 4 pieces to it, and we're just figuring out what's happening when we do a horizontal shift. So use the end points of the subintervals to find the 5 key points on the graph. So these are the zeros, max, and min. Those are your 5 key points, and then you should be able to draw the graph by now. So plot the 5 key points and extend the graph to make it complete. So usually I will ask you to draw 2 cycles of the graph, so be sure to read the instructions carefully. And if b doesn't equal 0, then at the end you might need to do a vertical shift, up or down. So we're going to do these together. So the first 2 we're just going to analyze, and then the first 2 we're going to actually graph, and the last one we're going to just analyze. So we're going to do those in class together, and we're going to spend a significant amount of time working on these graphs because they're challenging for a lot of students. So study, 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 and I'll see you tomorrow.